Welcome back to Simple Stats for STEM. This video is going to cover the procedures for running an analysis of variance, otherwise known by the acronym ANOVA, and we're still looking at math attitude. What analysis of variance does, it allows us to compare more than two groups. In previous videos, we looked at using t-tests, and those are good for comparing just two groups. But in this case, I'm going to compare a control group against two different types of tutoring and see if that makes a difference in math attitude. So you can see my null hypothesis here is that there's no statistically significant difference in math attitude among middle school students based on type of math tutoring. So maybe here in my first tutoring group, this is spending time with a teacher, perhaps in a classroom, going over homework problems. That's a one-on-one treatment perhaps. And then treatment 2 could be perhaps using some kind of a computer program and seeing if that makes more of a difference than spending time with a teacher, and especially compared to students who are receiving no intervention. So I've got control group, treatment 1, and treatment 2. So I'm comparing three groups on this dependent variable of math attitude to see if, first of all, if there's a difference at all, and then if there's a difference between these two types of tutoring. Be pretty interesting to know. I have already calculated the mean and standard deviations for each of these groups. I've covered how to do that in previous videos, and I've also created histograms and normal curves for each of the three groups. So control group and treatment 1, and then treatment 2. And again, I've outlined how to do that in some previous videos on Simple Stats for STEM, so I won't take the time to show how to do all those. But you can see that my data is, for my control group, is pretty normal. Treatment 1 is looking pretty normal. Treatment 2 is not great as far as normality goes, but we're still going to run this analysis and see what happens. So I'm going to run this a couple of different ways. And the first way I'm going to do this is I'm not going to use Google Sheets as far as a formula. I'm going to skip straight to Excel Miner. This is an add-on that we've used before. The Excel Miner Analysis Tool Pack, it is free, so you want to add on that free add-on. And then we're going to open it, and we're going to use what we call ANOVA with a single factor. With ANOVA with two-factor, we would be talking about two independent variables, such as math, attitude, and gender, or measuring the group on two independent variables. We're just using one. And so I'm going to go with the ANOVA single factor. Now for the input range, one thing on using Excel Miner is that these data sets have to be side by side. So what I've done is over here below my data, I have gone ahead and put those three pieces of data, or three groups, side by side on these measures. So I can just do this a little bit faster. So I'm going to highlight all three of those, and I'm going to use that as the input range. I'm telling Excel Miner that these are grouped by columns. So it's going to see that there are three columns here, and I'm going to tell it there are labels in the first row for control treatment 1 and treatment 2. And then I'm going to tell it where to put the output. Of course, the alpha is already set. The output, let's put that right down here. Actually, I'm going to scoot it over a little bit so it's not in the way of the histograms there. And that'll be my output range. And then from there, I just have to hit OK. So just to understand what this is doing, it's going to compare these three groups on their math attitude and see if there's a statistically significant difference between them. And we're going to assume it's based on the math tutoring concept. So here we go. Here's some important things for the ANOVA output. And really, some of this information we already had up top there. There's the averages. The variance is similar to standard deviation, but it's a different measure. But most of this we don't necessarily need for right now. Here's the important information. It's right here. Here's the p-value. So this is telling us that there is a difference between the three groups. Here's the S statistic. That is the output for the formula, the ANOVA formula. So those two pieces of information are really what we're after. Now this p-value is significant because it is, of course, we're always looking for a p-value that's less than 0.05. So this is telling us that there is a statistically significant difference between these three groups. What it's not telling us, however, is where that difference is. We don't know if that difference is between the control group and treatment 1, or a control group and treatment 2, or between treatment 1 and treatment 2. There are actually, I guess 4 different pairings of these groupings within ANOVA. So it's comparing all 3 of those pairings, or all 4 of those pairings, but it's not telling us which one is significant. So while this is useful, we want to take it a step further and understand exactly where that difference is. To do that, I could go through and use social science statistics. We've used this website before. and I could pop those values into these 3 treatment cells, and it would give me basically the exact same information that I have here. It would tell me the p-value, it would tell me the F statistic, it would remind me that this is a significant value, but it still would not compare those 3 groups one with another. So I'm going to recommend a different site for this one, and I'll put it down here. It is vassarstats.net, vassarstats.net, VASSARSTATS.net. And so I'm going to use that site to run this analysis. Vassar Stats will have quite a few of the same things that social science statistics has, but it's going to be able to give us a little bit more output on our ANOVA. So I'm going to click on ANOVA. I'm going to use a one-way ANOVA. And notice this could do up to 5 samples. We could actually compare 5 groups. ANOVA is a very, very powerful statistic. So one-way ANOVA, and I'm going to come down here and fill in some information. It's asking me how many samples or how many groups there are. So I'm going to say 3 and then click on independent samples. I don't have to worry about any of these things right here. Let's just get our data and put it into our 3 columns. So I'm going to come over here. It's made me take me a second to get my 3 columns. I will put those over into here. Notice that I'm not highlighting the labels on this go around, just the data. And I'll pop those in here. And this is going to tell me all the stuff I had before, but it's going to give me some other really important information here in just a second. So let's go ahead and calculate that. Boy, that was fast. And here is our ANOVA output. Notice there's the same p-value right there that we had before over when we calculated that using XLMiner. Notice it's the same p-value. It'll have the same S statistic as well right there. So this tells me the same thing I knew before, but VasserStats takes this a step further, and it tells me where the difference is right here. This is called the Tukey test. It's a post hoc test that the other sites don't run. It's telling me where the difference is. It's saying between group 1 and group 2, there is a very significant difference. Between group 1 and group 3, there's not a significant difference. And between group 2 and 3, there is a significant difference. So what this is saying is there's a significant difference between the control group and treatment type number 1, which I think we said was the spending time with the teacher. There is no significant difference between the control group and the treatment 2, which was using a computer software program. And there is a significant difference between the 2 different types of tutoring themselves. So this tells me a little bit more information that will add some more relevance to my information here. So I'm actually just going to copy this part right here, and I'm going to put that down here into on my page here so I remember what that is. Now there's one more thing that is really useful when it comes to ANOVA or with t-test or with correlation, and that is finding the effect size. That's going to tell us more than just knowing there's a difference. It's going to tell us how much of a difference there is. In other words, we know here, we've been told that there's a difference between the control group and the first treatment. There's a difference between treatment 2 and treatment 1 and treatment 2, but we don't know how much of a difference. We just know that it's significant. So we're going to calculate something called the effect size. And this is actually a very simple calculation. And what we're going to do is we are going to take a couple pieces of information from our ANOVA output right here. And by the way, this is the same output we had on all 3 of our sites. XLMiner, Social Science Statistics would have given us that, and then Vassar Stats, we got the same data here. If you check these values, they're all the same from what we got for XLMiner. So I'm just going to use these. The effect size can be calculated by taking this is called the sum of squares, by taking the sum of squares between and dividing it by the sum of squares total, which is this value right here. So I'm going to make it myself just kind of a little formula here. or a little fraction bar, and I'll do that simply by putting a bar between them. So this is my equation for effect size. It's a pretty easy calculation. So what I'm going to do is I'm going to build a quick formula, and I'll just say equals, and I'll say take this value and I'll divide it by this value and hit enter. So there's my effect size. What this is telling me is that if we had converted this to a percent, this is telling me that about 20% of the variance between these differences can be accounted for by the idea of math tutoring. So when I look at the scenario and say, yeah, there's a difference between control and treatment 1, there's a difference between treatment 1 and treatment 2, well, it's significant. We could stop there, but the effect size of this scenario at 0.2, it's a small effect. It's not huge, but at least it's one more piece of information to talk about this entire scenario, is that about 20% of math attitude is accounted for by math tutoring type. And we could continue taking it on from there. There's a whole lot more to be said about effect size, but that third piece of information is another valuable part of this scenario when it comes to dealing with ANOVA. So in this video, we've talked about how to conduct an ANOVA and how to compare 3 groups on math attitude. And we have our F-stat is a significant outcome. We know where the significant outcomes are from based on that Tukey test. And we know the effect size for the overall scenario is about 20%. Now you could conduct the effect size for these 2 pairings. You could actually run an ANOVA right here between these 2 groups, run an ANOVA between these 2 groups, recalculate the effect size for those 2 scenarios. This effect size applies to the overall picture. But you could run another ANOVA here, another ANOVA just using those pieces of data, calculate your effect size, and take it even a step further and get even more information out of that scenario.